The universe is a very dusty place, and every year tons and tons of that space dust falls on Earth. When the dust travels through our atmosphere, the particles burn up like tiny shooting stars or reach the Earth's surface as micrometeorites.
Micrometeorites are almost invisible to the naked eye. But these tiny particles make up for about 6,000 tons of space dust reaching the Earth's surface every year. That's 3 orders of magnitude higher than meteorites, their bigger counterparts. Micrometeorites are just all over the place, in oceans, on land, in your garden, and on your roof. But the problem is, it's so hard to distinguish them from other dust and pollution. That's why we like to hunt micrometeorites in a cleaner environment. Okay, stop. So why Antarctica? Well, it's definitely clean, it's dry, and it's not polluted yet. We are based at the Belgian Princess Elizabeth Research Station, and from there we mainly explore the Sør Rondane mountains. When we are out on our skidoos, we need to be careful not to fall into crevices. If we get badly injured, the nearest hospital is in South Africa. The old ice-free mountain tops are ideal places to find micrometeorites. The space dust has been piling up there for millions of years, untouched. Collecting is surely not the most complicated part of our mission. On our mission in 2018, we collected around 100 kilos of sediment that is estimated to contain up to 50,000 micrometeorites.
Back in the laboratory, the samples are first washed to remove the tiniest terrestrial elements. Then they are dried and sieved to separate them by size. A magnet can be used to extract micrometeorites, as these can often contain magnetite. Magnetite is a magnetic iron oxide formed during the atmospheric entry. The rest is then meticulously examined using a binocular microscope. Different methods can be used or combined to analyze the composition of micrometeorites. We can embed them in resin and polish them to expose their interior, which are then observed with an electron microscope. They can be dissolved in acid or vaporized to be analyzed chemically, but that's very destructive. A different cutting-edge technique employs a particle accelerator that bombards a micrometeorite with high-energy X-rays. We then use various sensors to detect X-ray diffraction to analyze the crystalline structure. X-ray fluorescence for the chemical makeup, and we can even create 3D inside-out scans. We can classify micrometeorites based on their composition and degree of thermal alteration. They range from unmelted particles to partially melted ones to melted round cosmic spherules. The unmelted micrometeorites are relatively rare, but provide a nearly unchanged chemical and mineralogical makeup. Determining the composition of micrometeorites facilitates the discovery of their origins in outer space.
Looking at micrometeorites is like looking at the birth of our solar system, some 4.5 billion years ago. They are the witnesses of how rocks and planets formed. Micrometeorites can contain particles from comets and asteroids. They can even contain material from the time when our sun hadn't formed yet. And we discovered that some micrometeorites are made of material never seen before in meteorite collections. There are big stories hidden in these small particles.